Requisite material for lesson number 6. We get into some more complicated expressions to evaluate. Lesson number 6 deals with two sample problems, and it just so happens the nature of the problems in two sample problems is are more challenging. So let's take a look at this. What we're doing here is we're calculating a z-score, also known as a test statistic. And it's a difference of two proportions, and we're going to enter in this information, which is provided over here. Now, to give you a little bit of context, when we see P1 hat, that's a sample proportion for the first sample. And when we see P2 hat, this is a sample proportion for the second proportion. So 54% of the second sample have some characteristic that we're measuring, and 62% of the first sample have some percentage proportion of whatever it may be that we're measuring. Maybe intends to vote for one candidate over the other one, or maybe, whatever it is, some percentage. Now, we always test P1 minus P2. P1 is the population proportion. P2 is the population proportion for number 2, corresponding with the sample 2, and of course corresponding with sample 1. And we typically just test that these two are equal to each other, which means the difference is equal to 0. Then we get into the mean of P and the mean of Q, which is part of the calculation. Then we get into the sample size. So the very first thing we do is just simple substitution, right? Put in 0.62 and 0.54, sorry about that, and put in 0.6 and 0.4 over the sample sizes down here. Now, the numerator is really simple, but the denominator can be a bit challenging. And shoot, someone has taken my calculator. So what I would recommend here is I would recommend the following approach for putting this in the calculator correctly and performing the operations, so you don't get caught up in a miscalculation. So I would probably prefer this approach. So I'm going to dive into the denominator and just calculate the part under the square root. So I'm going to have 0.6 times 0.4 divided by 50. And then I'm going to add 0.6 times 0.4 divided by 60, which is the sample size, okay? So when I get that, I get 0.008. Now, this isn't always going to be something that's nicely rounded off, in this case, to 4 places. It could be a decimal that's expanded infinitely. But anyway, what I've done is this part right here. So the next thing I'm going to do is do a little trick. So I'm going to do 0.62 minus the 0.54. And then I want to divide by the square root of the answer from the previous problem. Well, it turns out you've got a key right there that will allow you to insert the answer from the previous line. So when I do that, I get 0.852, which is exactly what I have here. The next test, or the it's actually called a t-score, that we'll take a look at, as again a sample mean for a particular population, a sample mean taken from another population, so population 1 and population 2. We have these population means, so we're testing that the mean difference is equal to 0. This is called the variance of sample 1. This is the variance of sample 2. Two parts that we have to enter, and of course we get the sample size. And by the same kind of logic we had before, what I would probably do here is I would take care of the denominator, the part under the square root. So let's do that. So we want to put that in parentheses. Again, just trying to teach you guys how to get these problems done correctly. This is not the way I would do the problems, Um, oftentimes what I teach to students who just aren't as experienced in this as me isn't the way that I would actually do it. So anyway, I get that, and notice how I have a decimal expansion. I want to store all of that. So that is this part right here. So just as we did in the previous problem, I'm going to take 18.2 minus 19.6. So in other words, put in the, or enter the numerator, and then I'm going to take the square root of the answer, close it with the parentheses, and I get negative 2.75. So that keeps me, by using this entire decimal expansion and not rounding off, or not rounding it to 4, 5, 6 places, it gives me more technical accuracy. Now, if you're just not digging that, and that's just not, you don't like the whole answer thing on your calculator, then just make sure when you round this off that you take it. So I calculated this part right here. Make sure you take it out to like 6 or 7, maybe even 8 spots when you take this divided by the square root of this answer to get your test statistic. Now the next one is a bit uglier. Notice that we're calculating something called the error. So we have a z star. The example I'm giving, it has a value 2.16. And then we have these values as well. So by simple substitution, I would, again, just enter the numbers to organize my work. And by the same logic as before, I would take care of this part. So let's do that. And then 0.18 times 0.82, 3128. So notice I say we have that in scientific notation, so let's regroup, and then that means let's not, because the e to the negative 4 says I have to move this decimal place 4 places to the left and fill in with 3 zeros. That could be a little bit confusing, but if I just leave it in the calculator as is, the calculator will make the changes. So I'm going to go 2.16 times what? The square root of the answer from the previous entry, and I get 0.023 as I should. All right, I hope this helps, and I hope that you're successful on the Coreq assignment number 6 in my stat lab. And I think if you follow the commands on your calculator exactly as I've done it, you will be successful at this. All right, take care.